Okay, this is some more from the practice quiz, and you probably noticed I had a little glitch in the, I had an overlap in number one because I actually ran over my 50 megabytes, so I had to re-edit it into two little small videos, which I know how to do. Okay, so that's why those are separated like this. We should have time enough on this one. This should easily fit within the 50 megabyte maximum I have at this time. Okay, finally, the absolute extreme. Here we are. This is the absolute extrema, and where they occur for f of x, and we have to find not only the x value, but we also have to find the y value, which is actually the absolute minimum or maximum. That's the value. Okay, so we know that on this closed interval, we just have to worry about any critical points. That's wherever the derivative is 0 or undefined, and the endpoints, that's all. So we put 0 in here and 4 in there, and that will give me my endpoint values. Then I got to check the value, that's the y, at x wherever we have a 0 derivative or an undefined derivative. So let's do our work over here. And this is the function, I already wrote it down. So if we take the derivative, just to check our critical points, f prime of x equals 2x minus 2. And again, that's not going to be undefined. Definitely a nice polynomial, but it can be equal to 0. So we just set it equal to 0. So 2x minus 2 equals 0. So 2x equals 2, so x equals 1. So that's my critical number for my critical point. So let's check the value for the critical point first. And we just have to put 1 in here. F of 1 will give me the value at x equals 1. And that's going to give me the critical point. That's where the derivative is equal to 0. And we can just, that's going to equal to 1 squared minus 2 times 1 plus 4. That's going to be 1 plus 4 is 5 minus 2 is 3. That will equal y. And that's for that's at my critical point. In other words, my critical point is the point 1, 3. Okay, and there's my value right there. Critical number, critical point, critical value. Okay, then I got to try the left-hand point. X equals 0. Well, it's f of 0. That's pretty easy. If I put 0 in here, I get 4. So for my left-hand point, I have the point that's on the graph that is 0, 4. And how about the right endpoint? At x equals 4. What's f of 4? And that's going to be 4 squared minus 2 times 4 plus 4. I just substitute that in. I just want to find the y value. And that's going to be 16 minus 8 plus 4. That's going to be 24 minus 8, which is 12, I guess. Let's see, let's try this again here. That's 20, pardon me. So that's 16, 8, and 4. So that's just going to be 12. There we go. Or 20 minus 8 is 12. So that's going to be the y value. So my right endpoint is just the point 4 and 12. Okay? And these are the values. Okay, which is the greatest? Well, the greatest is 12. And which is the smallest? The smallest is 3. So there you go. Okay, so we have extrema happening at our right endpoint and our critical point. And you could graph this if you put this in your calculator and look at that interval. I think you'll see it pretty much makes sense. So I go back over here, and then we'd want you to write absolute minimum at the minimum value is going to be, and you want to make sure that you stipulate this. So we're going to have at x equals, this is my minimum value at x equals 1. So at x equals 1. And my minimum value is 3. 2 points. And at x equals 4, my maximum value is 12. So that's all you would have to do for that. So I think that's pretty easy. Okay. Don't have to do the first derivative test or anything like that. Just have to take a survey of those values for those 3 points, the endpoints, and the critical number, or the critical point. Okay? So that's everything you need for number 2. And that should be pretty easy. Okay? So I hope that helps.